Hello everybody, it is July 2023 and here is the video on the scientific method. Actually, I'm going to divide this into two videos, each of about 20 or 30 minutes, depends on how fast I manage to convey the message. And that is everything about the scientific method as applied to the research on the global warming issue. But a lot of things that I'm going to say is also applicable to other areas of research and then science in general and about the society. It is based on, first of all, the one in the publication in Energy and Environment from 2014. Like always, I'm going to put a link to that in stallinga.org. If you cannot find it directly at the journal, it will have a link there. And the other one is, as we will see, is from a conference where I basically say the same thing, but a little bit later. So then the wording gets a little bit better. So in the next video where I talk about this second publication, that will be even a little bit, the things will be a little bit sharper set. But it's basically saying the same thing. And sometimes it's good just to hear the two things in two different ways. Now let me first then start about what is the scientific method, or what is science in general. Very often now in the media and even our scientists, they are saying sort of like, oh, I believe in science, or I trust the science. And that is, of course, is the most unscientific thing a person can say. It is basically then going back to religion. Since the Illumination, it is no longer that the truth comes from any authority. There is not something that a person or an institute or a book or something that you have to believe or trust. But since the Illumination, it is that actually everybody is allowed to think and reason for himself. So you, listener to this video, you are allowed to form your own opinions. You don't have to trust anybody. You don't have to believe anybody, not even me. You have the right to do your own thinking. And that is then you are becoming scientific. So actually when you're starting to doubt things, which we will see is actually the basis of science as well, when you're doubting, when you're a denier, let's say, then you start becoming a scientist. Not when you're a believer is that you're a scientist, then you're anti-scientific. So this is already the first important message that I put here right in the beginning, that no, it is not about believing, it is about using your own thinking and reasoning, and even actually, if possible, to do your own measurements, to find your own facts. So this publication here is called The Scientific Method in Contemporary Climate Research. And like always, or like a lot of the publications in this research about the climate, it's done with my colleague Igor Chmelinsky. And we are both more or less having the same point of views in this. As said, this is mostly about the anthropogenic global warming scenario that is plaguing our society. And the question is this science what they're doing or not? So let's delve into this. First of all, then, we will see actually that they are not doing science. So let's delve into this. The contemporary idea of the destructive effects of carbon dioxide, it comes from the paper of a publication of Roger Revelle in Scientific American. And in that, he said that carbon dioxide is changing our climate, and therefore he needs a lot of money from us to study the subject. Otherwise, we're all going to die. We're all doomed. So that is basically some kind of blackmailing that he's doing as a priest of the truth, that we have to pay him, or otherwise we will not survive. So that's already the first hint that maybe things are not so nice after all. The idea of Revelle is nothing new. Actually, it comes from Arrhenius, which in the end of the 19th century he also came with this idea. And actually, that idea of Mr. Arrhenius was already debunked by scientists. So why is this entire topic going to be resuscitated? Nobody knows. Well, I guess it's money. Never mind. Some years, 6 years after Mr. Revelle wrote this paper, the IPCC was set up, and the IPCC is now considered to be some kind of reference of the climate issue. which it's not, because as you know yourself, if you know what this IPCC stands for, it's Intergovernmental Panel on Climate Change. So it is a political institute, and a political institute is a human institution, has nothing to do with science. It's a human institution, and like any human institution or human organization, it suffers from the law of Angus, or the Angus's first law. And I will read it to you out loud here, because it's important that you understand it, that all human organizations tend to be self-amplifying. There is an effect which hamstrings all corporations, even the most effective ones. It is the natural tendency of any organization to become ever more like what it already is. This is called the self-amplifying tendency. The longer an organization has spent becoming more as it is already, the stronger is the force to pushing it in the same direction, like matter being sucked into a black hole. Eventually it will lose the ability to change at all, without recognizing how it happened. The IPCC, in other words, the IPCC cannot but say that there is a climate problem. You cannot imagine that one day they will say like, oh, you know what, we studied it, climate, it's not a problem. Let's stop all the funding to our institute because we are redundant. That will not happen. First law of Angus. They have what is called an idée fixe, or they are sort of like climate. They're now political climate fanatics, and they're getting bigger and bigger, and it's like a big black hole that is sucking all our money and power. Churchill called this a fanatic is a person that cannot change his mind and does not want to change the subject. Now, the main problem therefore is that the IPCC is constantly looking for proof of their ideas. And there already you can smell that something is going wrong, that this is not the way the things should be handled. And as an idea, they're constantly saying that, oh, today was the hottest day since measurements have started, or it was never so big flooding in Pakistan as before. This is all signs of climate change. That is not how it works. We will see this in a moment, that this is the opposite of science. You can also see this by that they're looking for proof of their ideas by the so-called climate gate, the emails between scientists or pseudoscientists, and they demanded from each other the production of nicer data to convince the public at large that anthropogenic global warming is real. That is not how science works. We already can smell that something is fishy. This doesn't have some kind of scientific ethics. So then, what are these ethics in science? What is science? What distinguishes science from, let's say, technology or engineering? I will answer that in this and next video. But we then first go here to define what is science. And science is then, in its self-referential way, described as science is that what is using the scientific method. And that is the video for today, the scientific method. And this is based on the work of famously Karl Popper, who has the scientific philosophy, the great scientific philosopher. But they also like the words of Richard Feynman, who can say these things in an actually very nice way. I recommend you to read The Character of Physical Law. And it basically has 5 points. In this one, I have only 4 points, as you will see. But actually there are 5. In the next video I will put it even more. I will add 1 more point. But in this one I will talk only about 4 points. And once again, after having written these 2 publications, there came always a 0th point, which is sort of like intrinsically, which nobody mentions. And this 0th point is that science is about the real world. So not, for instance, mathematics. Mathematics is not science. Mathematics is a virtual world created on basis of axioms and then reasoning within this world. And in mathematics you can prove something correct. In science you cannot prove things correct, you can only prove things wrong. You can prove your thesis wrong. But so the first thing is the real world. The first point the 0th point. And the first point then is that we're going to do measurements, data collection and so on, and to measure the real world. And then based on this data to form an hypothesis. And then the first thing we should do is to find out where our hypothesis, where our model fails. Where our model fails. And look again here what the IPCC is doing. They're looking for proof of their ideas. So the IPCC and all the scientists contributing to them, they are already failing at the first point. They are trying to prove where they're wrong, where they're right. While they should be out there, they should be skeptics. They should be looking where the models are wrong. But of course, they are not scientists. They're politicians. All of the people at the IPCC and all of the people contributing to them are actually not scientists, but politicians. Second point, the creators of the model should convince the readers that it's not the only model that can explain data. So basically, you should reject other hypotheses. And there we have another problem, as we have shown in our already in our own research, that for instance for the correlation between carbon dioxide and the temperature, which they say is the greenhouse effect, they never convinced us that the alternative explanation, namely Henry's law, is actually can be rejected. And as we have shown in our videos and in our publications, Henry's law seems to be doing quite well. There is no need for the greenhouse effect. Where the greenhouse effect is very dubious, it doesn't make much sense, Henry's law can explain everything. Please see our videos and our publications on Henry's law that I've already recorded some days ago. So once again, the IPCC is not using the scientific method because they don't use the second point to prove to us that it's the only model that can explain the data. The third one is that any hypothesis that you bring out there, it should be able to be debunked. And it should have something that is predicted for the future, not just predicting the past. That is called retroduction and it's useless. You should predict something that has not been measured yet, let's say. You should make some prediction that then distinguishes your model or your hypothesis from the other. So it's basically the attempt to show the other models wrong. Then you should say that, well, if this and this and this happens, then I will be wrong. Or if this and this and this happens, their model will be wrong. You should not try to prove that your model is right. You should try to prove the other hypothesis wrong. As an example, Mr. Einstein predicted that at the solar eclipse that there would be seen the ray bendings and the stars would not appear at the normal position. So they went there and they saw that yes, indeed, as predicted, Newton is wrong and therefore Mr. Einstein is right. If you just say what is possible in the previous data, then you're just doing what is retroduction, and then well, that is not very useful. Also note that there's nothing things like we're not going to vote. It's not about if you have 1 million pieces of evidence that are supporting your model, and there's one piece of evidence that is against your model, then you would say like, well, 1,000,000 to 1, our hypothesis is still correct. That's not how it works. A single piece of evidence can prove a theory wrong, while 1 million pieces of evidence cannot prove a theory correct. Because there may be more models that can prove that is consistent with the observed data. So if one piece of data, for instance the bending of the light at a solar eclipse, that was then the proof that Newton actually is wrong. And it doesn't matter that you could predict 1 million times the planetary orbits and so on. The fact that the bending is not predicted by Newton, therefore Newton's theory are wrong. In other words, there is no such thing as corroborative evidence. No amount of experimentation can ever prove me right. A single experiment can prove me wrong, said Einstein. And there we go again. What they're doing, they're constantly looking for 1 million pieces of data that their theory is correct. So they're constantly saying on televisions and so on, oh, again, this was the hottest November since the records and so on. Yes, so what? Is it the only theory that can say that it's warming up? No, it isn't. Please take a look at the theories of Mr. Svensmark. He has a very convincing theory how the solar activity then influences the climate. And I cannot see how this theory is wrong. It seems to be consistent with all the data. And as we have shown in previous videos and in our publications, the idea of the greenhouse effect, that is simply not consistent with all the data. So I can show you, I showed you some data that is completely contrary to the idea that the greenhouse effect is actually determining our climate. So once again, no amount of experimentation can ever prove me right. A single experiment can prove me wrong. Also the word consensus, I will leave this to the second video. Consensus is not a word that can be used in combination with scientific statement. That is again because it doesn't matter that there's 1,000,000 to 1. It matters the one. And in other words, you can also say a theory is correct until proven wrong. So that is basically saying the same thing. To show you an example how before science was done correctly, and nowadays it isn't anymore, by the way, the American physicist Robert Millikan set out to disprove Einstein's model and wound up confirming it in every detail. Einstein and Millikan each got Nobel Prizes out of the deal, meaning that Robert Millikan was basically trying to be a good scientist and to prove Einstein wrong. And because he was such a good scientist, he proved basically Einstein right by not being able to prove him wrong. And therefore, he was such a good scientist, he got the Nobel Prize. That doesn't work nowadays anymore. Nowadays, you get Nobel Prizes for having relevance in society, like maybe this one about the ozone layer or something like this. And even it doesn't have to be shown that it is correct or anything or whatever. It is because it's important and it has relevance in society. If there remain a couple of models which can explain the data, so you have to try to show that you're the only model, your only thesis can explain the data. But if for some reason there still remain models that are both able to explain the data, in that case you have to take the simpler one as being the correct one. This according to William of Ockham and Saint-Exupéry, that said that a model describing reality should not be more complex than necessary. This, for instance, the IPCC didn't do, because they never managed to show that a constant climate, which actually the data are still within a constant climate, and on top of that some kind of fluctuations, or a linear model in which we are linearly warming up, they have not rejected it yet. So that means that this is still able to explain all the data, and therefore, according to Occam's razor, as it's called, this is still the correct one. That is at least according to science. Now, point number 4 here, after you have finished all your work, after you have done everything, after you have formed an hypothesis, try to break it down yourself, having shown that other hypotheses don't work, and after having done some experiments that only your thesis could predict, then after having done everything, then you can send it to your colleagues and saying like, you have to show like, look, I've done my best, I've done a good job, but my work is done because, for instance, imagine that my hypothesis predicts that the currents cannot be more than 10 amps. And then I try to measure, I try to find 20 amps measurements, but I didn't find them. Meaning then, okay guys, listen, in my experiments, in my laboratory, I cannot prove myself wrong, but you're not measuring currents, you're measuring voltages. Please, you have a go at it, because my hypothesis also predicts something about voltages, but I cannot do this. So this and this and this is my hypothesis, my theory, and these are the data that I used. This is my reasoning. And therefore you can repeat my experiment. then let's see how we all come work together and make science itself, the entire scientific system, scientifically correct using the scientific method. Okay, so these are these 4 points. In the next video I will actually add another point, or I will say it a slightly different way, but this is basically it. Some observations. That science is not aimed at making the world a better place. Forget it. That is technology and engineering. And of course, everywhere in the IPCC, they're using this data that prove their model right. So again, once again, the IPCC is a political body and not a scientific body. An example of their wrong approach is that they created the so-called hockey stick that you probably are familiar with, and that was in 2001 used to prove global warming, and everybody was waving the hockey stick around and say like trust the science or something like this. Well, that one then that one was done by Mann, and that was based on actually a wrong approach of processing the data, and he was asked to hand over his data and his model and his reasoning, and he refused. But anyway, he was put in court and had to hand it over, and then it was shown that the entire hockey stick was actually basically not correct. So this IPCC, Mann is a big member of the IPCC committee. He again, he did not want that other scientists were repeating his work. Let's see. But they also, for instance, what they forget, you should say in here in point number 4, you should show also where your theory is on thin ice, where things are not done so well. And you should show that what might somebody have against the model. And for instance, they forgot to tell readers where their model fails, namely that in the data of Mr. Al Gore, which you probably all know, of the correlation between the carbon dioxide in the atmosphere and temperature of the planet. They forgot to tell us that actually in this data the carbon dioxide is lagging behind temperature. Now think about that. How could that be? That the planet knows that it's going to heat up because in a moment the coarse carbon dioxide will increase. Basically, once we understand it, it's game over, and they forgot to tell us. That is scientific fraud. If they forgot to tell us this very important fact. But of course, fortunately, there were skeptics like myself, but before me already a lot of other people that pointed it out. And these people that are called skeptics, they don't believe, they don't trust the fellow scientists, not even fellow scientists. They don't trust the word of an international political committee. So they find out that actually that the CO2 is lagging behind the temperature. Game over, I would say. So praise to all the skeptics in this world, or as Descartes wrote, doubt everything until that which cannot be doubted is left. Or Woods in the History of Philosophy describes it as the very process of scientific controversy, discussion, constant re-examination of positions backed up by observation and experiment leads to a deepening of our understanding and a closer approximation of the truth. In other words, doubt, discussion and skepticism are the sound elements of science. Skepticism is the closest thing to science you can get. This I already said. Let me see what more did I want to say. The IPCC research doesn't meet the third criterion of the scientific method, namely containing a verified prediction. That is to say, they said it would was going to warm up already by about 1.5 degrees, 2 degrees, and it didn't happen. So if you look at it, their prediction is further off than predictions of constant climate and prediction of linear increasing climate. Once again, Occam's razor, the data, then we should say that then the linear increase in temperature is correct, and their models of IPCC, they are wrong, simply from the data. What they also did was retroduction. So imagine until the year 2000, they had data, and then they formed a model, and from that moment on, the history, it continued. So in 2010, they then had data that they did not predict. So they could predict, the model from 2000 could predict the data until 2000. And in 2010, they had data that is not predicted by the model of 2000. So what did they do? They adjusted their model, and then they said, like, you see, now we can explain all the data from up to 2000 and even up to 2010. And then immediately they are sinning against the second point here, because they should have done to convince us that's the only model that can explain reality. So in 2000 they said they had the only model that could explain the data until 2000. And in 2010 they said, well, here's another model that can explain the data until 2000. So they did a very sloppy job, at least in 2000. And then we should believe them in 2010? Not me. As they say, fool me once and the shame's on you. Fool me twice and the shame's on me. Where did we go here? Yes. They did Bayesian changes of the model, which is not allowed. That you can change the parameters and so on after a while. That it again explain all the data from the past and again do a perfect retroduction. That is not how it works. That is not the scientific method. Here another one. Then they say, of course, they're constantly looking for for proof of their model that it's getting hotter. And then they found out that, well, it's not getting so much hotter actually. And we have another explanation for that. And they say it would get much drier in the world. Well, they found out it's not getting drier in the world. It's also not more windy. There are no more storms. There is no more storm damage. It's not drier. It is not wetter. It is not more stormy, less stormy, more snow, less snow. There is nothing going on. So all these predictions were debunked. And then they said, well, you know, it's the weather is getting more extreme. And that is very nice, because then every piece of data can be used to prove your model. So if it's more snow, it's climate change. If there's less snow, it's climate change. If it's drier, it's climate change. If it's wetter, it's climate change. If it's hotter, it's climate change. If it's colder, it is climate change. Wind, climate change. More wind, less wind, climate change. And this, of course, is, well, you guess it already, if everything is a proof of your model, then your model is not scientific. There must be a way, once again, let me show you here, there must be a way. The model should include a verifiable prediction, an event happening in the future that can debunk your model. And the nicer it is, the easier it is to find data, to possibly in the future find data to destroy your own theory, the stronger is your theory if it is not destroyed. And a model, a hypothesis that cannot be by any piece of evidence can be debunked is not scientific, it's religion. And that is exactly what they have done once they started telling about that the climate is getting more extreme, that there are more extremes. Because then every piece of evidence is every fact will be proof of the model. And then they even rewrote the scientific method, the scientific way of doing things. And for instance, it is done by Mr. I don't even know, Stott and co-workers, where they write, and this listen to how bad this is. Currently, attribution of single extreme events to anthropogenic climate change remains challenging. In the past, it was often stated that it simply was not possible to make an attribution statement about an individual weather or climate event, which is basically true. However, scientific thinking on this issue has moved on, meaning that they are insulting previous scientists. They were stupid, right? And now it is widely accepted that attribution statements about individual weather climate events are possible, provided proper account is taken of the probabilistic nature of attribution. That was then a reference to a Nature editorial. That is of course very insulting of Stott, that you just say that previous scientists were stupid and I'm the smart ones. And on top of that, he is misciting this Nature publication, because they don't say that it's possible. This Nature says that the public would like to hear such statements from scientists. There is a market for them, and this gives Stott and co-workers raison d'être. So Stott is just basically, he's abandoning the scientific method just for 20 silver links or something like this. Okay, let's continue. This I already said. And I want to finish here with the idea that don't forget that a vague theory, something that is not clear based on physical laws and so on, that can be tested moreover in a laboratory, that is that's not scientific. So what are they doing? They're making a so-called finite, a lot of them, finite element simulations. So they make a simulation in a computer, and they don't know themselves even what's going on in the computer. Some parts are based on the physics laws, and some parts are just fitting parameters, adjustment parameters. And let me show you how this works. Imagine we have this figure here, and we have here in this triangle, there should be an A here, that is the transfer function, that if I change here the carbon dioxide in the atmosphere, how much will it change the temperature? In a direct way. Physical laws. These ones you can test in a physics laboratory. Just put a chamber with carbon dioxide or whatever and measure the temperature. Well, you can do it. But then what do they do more in these finite elements computer simulations? They put parameters such as this beta, which is called feedback theory. And as you can see here, that the total transfer function from carbon dioxide changes here on this side to temperature changes on the other side is given by A divided by A1 minus A times beta. Just do the calculation here. Unfortunately, I don't have here the equation, but I'm sure you can do it yourself. And 1 minus A times beta, that means that if beta is close to A, this thing can even go to infinity. And this is what they want. They want it to have a very strong effect of carbon dioxide. It's not based on physics laws measured in a laboratory, but it is what is needed to explain the data, retroduction, and then you say like, then we're all doomed because we're going to heat up a lot. And yes, that is true. Look, if this beta is correct, and A times beta is close to 1, which the fact is the case, then they would say that this actually can result in a runaway scenario. That you get here 1 millikelvin, and then you get in the cycle, 1 millikelvin, and in the cycle you get 2 millikelvin, and 4 millikelvin, and 8, and you can have a runaway scenario. That, however, is then based on this beta value, which just by coincidence is very close to 1 divided by this parameter. And on top of that, what do you get then? Then this is called, we call this instability in feedback theory. And then this, they will also then talk about, we have only 96 months to act, otherwise we reach a tipping point. And this ideas of tipping points also comes from this feedback theory, and it comes from this beta parameter, which by coincidence is very, very close to A, but this is what they need, and this is what they need to execute their political agenda. The entire idea, or the way they're doing it, is the same how they did to predict the weather. And don't forget that it has taken, let's say, 10,000 iterations. Since we're doing weather predictions by the computer, 10,000 iterations. So the weather is, let's say, a couple of days. And then they can get a 5-day prediction reasonably correct. So it would, if we use the same method, after 3,000 centuries, we will be able to predict the climate more or less correct. So this method, through finite element simulations, will not result ever in good climate predictions. So also they didn't use replication. To give an example, I asked once somebody to give me the code, which they're obliged to do, by the way. If they are scientific, they're obliged to do. And they just told me, no, we will not do this because you will not understand it anyway. And that means then that they sin also on this fourth part, that I can do replication of their ideas. And they said, no, you will not ever replicate our work, you just have to trust us. And trust is not part of the scientific method, as I told you already. So, in this part already, we conclude that the alarmist, the IPCC, which are alarmists, research fails to meet all 4 fundamental criteria of the scientific method and can hence not be called science. In the next video I will say this again, and I will say some more interesting things. So see you in the second part of this of these 2 videos. See you in a moment.